Okay, here we are with another problem. We're going to use the root test on this one. Problem C in exercise 2, example 2. Okay, so you set it up like so, and you find this limit. So this is just n over 500, which goes to infinity. So we know this is divergent by the root test. Okay, let's skip down. Let's do D. We've got this one. So typically, as soon as you see that fractional exponent or that variable exponent with the index n there, that indicates you should probably use the ratio, the root test. So we're going to have this. Which then becomes this. Okay, now this goes to infinity, but you can use L'Hopital's rule. You have 1 over n over 1, and then that ends up being 0, which is less than 1, so by the root test, convergent. Okay. Now, let's take a look at this. Let's do E also. Okay, so got this n factorial to the n and n to the n squared. So that's a little kind of crazy. Okay, but we'll try the root test. So we've got the nth root of n factorial to the n. And down here, I'm going to write this as n to the 2n. In fact, I'm going to write it this way, with that n on the outside, because this will then just reduce to n factorial over n squared. And I think, even though we can't use L'Hopital's rule on this, you probably suspect that this thing heads to infinity, and that it then therefore tells us it's a divergent series. But you could expand this a little bit. You could write this as n times n plus 1 factorial, an n and an n, and then that's a little better. Still infinity over infinity, not quite a determinate form, but you could do a little bit more. You could write n plus 1 over n times the n factorial. Oh, well, you know what? I take that back. That was n minus 1. Okay, n factorial becomes n minus 1. Okay, so this is actually a minus here. Let me see, may I get that out of there? Whoops, there it is. Okay, and it's a minus 1 like that. Okay, and then we have the n minus 1, and then this part over here. Let's see. Let me fix that. Okay, that would become an n minus 2 factorial. Okay, so the reason I did that was because now this we rewrite that one more time. We do that division in here. You know, you can do the n minus 1 divided by n is 1. So, oh, sorry, I don't need to do all that. I'm just going to write 1 minus 1 over n. It's a lot simpler. Okay, so forget about that. Now, what happens here? Well, this thing heads to 0, which means I just have a 1 here, and this heads to infinity. So it really does head out to infinity, and then we have divergence. So we knew this was going to happen at this point here. I mean, that factorial is just way larger than n squared. So for a large enough n. So anyhow, okay. So